Hi, welcome to Computer Organization. I'm Bryce, and I really enjoy teaching this class because it's the first place in the computer science curriculum where you get to see how computers actually work. To do that, we'll begin with the fundamentals of how computers represent information using binary numbers and Boolean logic. Then we'll build circuits to perform arithmetic and store data, and use those circuits to construct a central processing unit. Next, we'll see how that CPU can be programmed using assembly code, and how compilers translate the programs that we write in high-level languages like C into assembly instructions. Finally, we'll learn about how the operating system manages a running program, including how your program actually accesses the hardware and how it interacts with other threads and processes. Along the way, we'll also learn how to program in C and how to navigate the Linux operating system using the command line. I find all these topics where we're learning what goes on inside the box really fascinating, and I hope you do too, but it's also worth asking why this class is required for the computer science major. The first reason is that knowing what's going on under the hood can actually make you a better programmer. For example, when we talk about caching and the memory hierarchy, we'll see that the order in which data is stored can make a big difference in how fast your program runs. The second purpose is to provide a foundation for upper-level systems classes. For example, if you want to take an upper-level class in operating systems or networking, it'll be helpful to know about the other parts of the computer system that your code interacts with. And you'll need to know some C programming and be comfortable with the Linux operating system. I'm currently in our classroom, the Watson 132 Computer Lab, where all of these computers run Linux. So in the rest of this video, I'd like to show you how to get set up to work on these computers, and also how you can connect to Linux from anywhere on Davidson's campus. When you're here in person, you can log into the Linux computers using your Davidson email and password. When you arrive at the desktop, the Activities button in the top left, or equivalently the Windows or Command key on the keyboard, will bring up the Applications bar, as well as a search bar that lets you run other programs. We'll primarily be using three things this semester: a web browser, the terminal, and a code editor. For me, Firefox already appears in the toolbar, but if I want to run the terminal application, I'll need to search for it. And since I'm going to be using the terminal a lot, I can reopen the Activities menu and right-click its icon to Add to Favorites. The terminal gives us a text-based interface for navigating the operating system and running programs. But one thing we'll often want to do is to switch back and forth between the graphical interface and the command line. If I bring up the File Explorer and have navigated to some folder, and now I want to open that folder in the terminal, I can right-click and choose Open in Terminal, and that will give me a new command line at that location. Conversely, if I have a location open in the terminal and I'd like to open it in the File Explorer, there are various commands to do that. One that we'll talk about in class is xdg-open dot, which behaves as though I had double-clicked on the current folder to open it. The primary code editor we'll be using this semester is VS Code. Once again, I can open the Activities menu and search to open VS Code. And again, I'm going to want this all the time, so I'll add it to my favorites. From within VS Code, we can open a particular folder that contains code we want to work on. But if we've opened that folder in the terminal, we can also start VS Code there from the terminal directly. With the command code dot, I can open the current folder in VS Code, and then any programs in the current folder will appear in the sidebar, and we can open them up to work on them. One more thing I want to do to get set up is, in Firefox, I want to bookmark our course Piazza page. I'll go to piazza.com and log in. And then, since I'll want to check on this most classes, I'll add it to my bookmarks with the star. At the end of class, or when you're done for the day, make sure you remember to log out. The menu at the top right has the power off, log out option. And if I log out, it'll take us back to the login screen so somebody else can use this computer. But sometimes you'll want to work on the code that's saved on Linux from somewhere else on campus. So let's go over to my office and I'll show you how we can connect to Linux remotely. If I want to work on our Watson 132 Linux system from somewhere else, like my office, I can connect using SSH. And for our purposes, the easiest way to do that is using VS Code. There are versions of VS Code for Mac and Windows and Linux. So I recommend that you install VS Code on your own computer. If you go to code.visualstudio.com, you can download and install the appropriate version for your system. Once you have VS Code installed and running, there are a couple of extensions that I recommend adding. In VS Code, the left-hand bar here has various useful tabs, including extensions. The first extension we want to add will help us with C coding, and that's the C++ extension pack from Microsoft. So make sure you're getting the extension pack from Microsoft for C++. I've already installed it, but you'll have an install button here. And then to connect remotely, we'll want the Remote Development extension. Again, this is an extension pack from Microsoft, and once you've installed it, you will have a tab called Remote Explorer on the left-hand side of VS Code. But before we try out the Remote Explorer, let's use SSH to connect using just the terminal. In VS Code, there is a built-in terminal. If it's not already open, you can get it from View, Terminal, and you can use the right-click menu to change where this appears on your screen. Right now, the computer I'm using is actually a Linux computer, and so this terminal inside VS Code behaves identically to the Linux terminal on my computer. But if you're on a Mac, then the VS Code terminal will run the Mac terminal, and if you're on Windows, it will run PowerShell. And all of those programs allow us to do the terminal commands we need to connect remotely. In particular, we'll use the command SSH, which stands for Secure Shell. When I run the SSH command, I'll need to type a space, and then the username and computer that I'm logging into. My username is my full Davidson email, and then I need another @ sign, and then the name of the computer, which in this case is mcsdev0.rc.davidson.edu. It asks if I'm sure I want to connect, and I'll tell it yes. And now the terminal shows that instead of running on my office computer, it's now running on the mcsdev0 computer, which is the server that TNI has set up to let us remotely connect to our Linux system. If I now run commands like ls to list the contents of the current directory, those commands are being run on the remote computer, and we see the contents of my home directory, which are exactly the same as what I saw when I was sitting at the computer in Watson 132. If I want to log out of this remote connection, I can type exit. And now my terminal is back to running on the computer in my office. But now, thanks to the Remote Development extension pack we installed, we can use the Remote Explorer tab to make this connection even easier. Let's open this up, and it shows us the SSH targets. And right now we don't have any set up, but we can create one with the plus. And here it asks us to enter an SSH command, and I'm going to copy and paste exactly the same SSH command that I just ran in the terminal. And if I hit enter, now it asks me which configuration file I want to update. The top option here is my home directory /.sh/config, and that's the file I want to use, so I'll select it. And it tells me that the host has been added, and in my SSH targets, I now have mcsdev0. But I can make this even easier by renaming this host to something easier to remember. I'll do that by going to the configure gear icon here and opening the config file that I just updated. And in that config file, we see that it has saved the name of the computer we're connecting to and the username we're using to log in. And those we want to leave unchanged, but we can rename the host to anything we want. In particular, I'm going to call that host Watson because this is how I want to access files that I save when I'm working in the Watson 132 lab. I'll go to File and save this configuration file. And now we see that the SSH target has been renamed to Watson. And one thing that's great about that is this configuration file is read not only by the Remote Explorer, but also by SSH from the command line. Instead of typing out this whole username and computer, I can now just run SSH space Watson, and it correctly connects me to this computer with this username. Of note, when you do these SSH commands, you will probably have to type a password, but in class I'll show you how we can set up the authentication tokens so that yours works just like mine. So what can we do with SSH? Well, for one thing, we can copy files back and forth between my computer and the Watson computers. Let's log out so that my terminal is back on my computer. And in the File Explorer, I see that I have files named hello.c and hello.py in the current directory. I could also see that with the ls command. And if I want to copy one of those files over to Watson, I can do that with the command scp, which stands for Secure Copy. For this command, I need to give it the name of the file I'm copying, hello.c, and then after another space, I need to give it the destination where I'm copying it to. In this case, that's Watson, followed by a colon, and the place I want it to be saved on Watson. And ~/ means put it in my home directory. If I run this command, it copies hello.c, and now if I SSH to Watson again, and list the contents of my home directory, it now includes that file hello.c. I could also use a similar scp command to copy it back from Watson to my computer. In that case, I want the first argument of scp to be the location on Watson that I'm copying from. So that's ~/ hello.c. And then I need to tell it where to copy it to. So I'll say space dot, where dot stands for the current directory. And that command has overwritten hello.c with the version that was copied from Watson. But even better than running SSH and SCP in the terminal, we can use the Remote Explorer tab to actually open an instance of VS Code that runs on the remote computer. We do that with this Connect to Host in New Window button, which will create a new VS Code instance that is setting up an SSH connection. And this will take a minute. But when it's done, I can choose to open a folder, and if I open my home directory on the Watson computers, we'll see that that folder contains the hello.c that we just copied. And if we were to modify that file and save it, and then come to the terminal, note that this terminal is also running on MCS Dev 0. So if I use the cat command, which dumps the contents of a file to the terminal, it will show the changes that I just saved to that file. But if I go back to the VS Code that's running on my computer and cat hello.c, it will show me the original version of the file. So using the Remote Explorer, we can run an instance of VS Code that sees our files on Watson, and when we make changes, it will save those over the network onto the Watson file system, and we have an instance of the terminal running on that computer as well. Now that we've set up VS Code and our SSH configuration, it should be easy for us to do our work on the Watson Linux computers, whether we're physically sitting in the lab or anywhere else on campus.